Hi everybody. State the precise definition of the improper integral right here. Okay? And then give one example that's convergent and one that's divergent. Okay, so first of all, let's just do b. Remember that the sum of 1 over n squared is going to be pi squared over 6. We have not shown this, but the sum of 1 over n, and this is over all natural numbers, or maybe it's positive numbers. This is over positive numbers. This one is equal to infinity. In other words, it's not equal to anything, and it does not exist. We could say it diverges, etc. Now, these are not integrals, right? These are not integrals. But in our heads, we can remember that we can use the integral test, and we can look at the integral from 1 to infinity of 1 over x squared. And the antiderivative here, if this is little f, what's capital F? Well, if I have x to the negative 1 and I take the derivative, I'll get negative 1 over x squared. Well, that would be almost right, and so really the antiderivative is negative that, and that would be positive that. And so that's how I remember. Well, f of b, but I can't plug in this. I'd like to do minus 1 over infinity minus 1 over 1. Sort of plugging in infinity and 1, but this is not a number. We'd like to say this is 0, and so what people do is they say, well, the limit as x goes to infinity of negative 1 over x minus negative 1 over 1 is equal to, well, this part has nothing to do with x, and so this is just going to be a plus 1. And this part will go to 0. And so we say it's equal to 1. Okay. So that's an example where the improper integral is convergent. Okay, let's do a divergent one. Well, this harmonic series diverges, and so sort of the associated integral should probably diverge. What's an antiderivative of 1 over x? Well, some magical words, log of x. Apparently, we're led to believe that the derivative of this is 1 over x. In fact, that could be your definition of log of x, is that it's the antiderivative of 1 over x from 1 to some number. But anyway, our book doesn't define logarithm, so we're just going to treat it as a magical symbol. Okay, so limit as x goes to infinity of ln x minus ln of 1. We're plugging in the bottom. Well, ln of 1 is 0. Remember, the graph of ln looks like this. ln of 1 is 0. Okay, and ln x just gets bigger and bigger and bigger and bigger forever, and actually gets arbitrarily large. It just would take really long going out that way. And so these are just magical results that we're supposed to believe. Okay, now let's state the precise definition of this improper integral. So here was b. This was b. I just gave an example of a convergent and divergent. Okay, now let's do a. 1 to infinity of a function f is defined to be the limit as, well, I don't know, we can go from 1 to b, some real number b, and, do f of x dx or whatever, and compute this integral. This will be just a finite number. So we're assuming that the function f, actually it makes sense to integrate it, and we get a finite number. Like somewhere here's 1, maybe over here is b, and somewhere is the graph of f, and this is a finite area that we call this number. Okay, this refers to this area. Okay, so, but what does this mean? What precisely does this even mean? We have an intuition for what it means. It should somehow be a limiting value of these areas. Let's imagine that the function f gets smaller and smaller as we go out to the right, and that the total area here is somehow finite because this gets so thin. Okay? So we imagine that this could possibly be a finite number because this part gets so thin that we get a finite number, and we don't really know what this means. So what does it mean? Well, this means, so what's the precisely does it mean? Give the precise definition of this thing. It means that there exists, well, if it converges, so the limit as b goes to infinity of 1 to b f converges if there exists a number w. We've been using w for the limit, although it was usually a complex number, but now we're thinking it's a real number. If there exists a real number w such that for all d there exists a capital B such that when this is big enough, if we put b far enough out, that implies that we are within d of this limit, this number, this area. And, well, there exists a bound, maybe capital B is here, and as long as we integrate out to like a little b right there, and we cut off our area, then this area will be within d of this number w. And so let's fill this in. Integral from 1 to little b of f. So this is a number. This is a finite number. That we supposedly know how to calculate using the fundamental theorem of calculus. Oh, and then I need subtraction. So the difference between these numbers is small. In fact, it is as small as you like, because we require that this holds for all small positive real numbers. There exists a bound, some cutoff real number, such that if we integrate to some little b past that cutoff, then this implies that we're within d of the number w. Okay, so to be clear, you would just write, if for all d positive real, there exists some place where going past that place and then integrating to that little b, the function, gives a number which is within d of this limiting value. Okay. So if there exists, yeah. Anyway, so that's what it precisely means. And now, I also gave you some pictures and intuition. You don't have to include that in your answer, but you do need to include the precise definition with the correct order of these logical things. These are like for all there exists. This implies, like all these things are important. Now you should understand what they mean. To understand what they means you could fill in like pictures and explain it to me. you should be able to do that. But it doesn't really ask you, it just asks you for the precise definition. Okay, so that's part A. Let's look at my other answer too. So I was quizzing myself. Right, so set a 30-minute timer and just quiz yourself repeatedly with lots of blank sheets of paper where you've written this question somewhere so that you can see what the question is asking, and then just repeatedly try to solve it, and then look back at the video, and then quiz yourself, and then look back at the video, and then quiz yourself, and maybe read the book because the video isn't helping anymore, and then quiz yourself, and then etc.